Everybody, today we're going to be drawing triangles with given conditions. I got the odd ones, you have the even, so let's start with number 7. Draw two different triangles with angles measurements 90, 35, and 55. Well, as I remember, 90-degree angles are right angle. And then we could have when it comes like this, and we could say this is 35. And this is 55. The only trouble is, without giving the length of the sides, I can still come up with a different size angle, or a different size triangle, I should say. 35, 55. The triangles will not look new, or they will not look the same, excuse me. But they do have the same measurements. Okay, let's go to number 9 now. And this was 55. How can you make different looking triangles given two of the angle measures and the included side? Well, if I give two angle measures and the included side, let's see, two different looking triangles. Well, I could make one that is, 4 inches. And that's the, and including the side length, so that's 1. And then I could have a measure of, let's see, 20, no, make it 25. And that will leave us with, let's see, given two angles, we can make one of the angles a right angle. 90 and 25, well, 90 minus 25, I should say, will give us 65, so this must be 65. And if I'm going to get two different looking ones, I can't remember that I can turn these, right? So this one up here could actually be 65, while this one is 25. And we can keep this one right there the same. All right, let's do number 11 now. Number 11 says, how can you make different triangles with the same angle measures? Well, we answered that right over here at number 7, right? We have the same angle measures, different triangles, and we just increase the length of the sides to make different ones. So use different side lengths would be our answer. Okay. And let's see. And let's see, number 13 now says, a student was asked to form different triangles with the angle measures 90, 30, and 60. She incorrectly said, this triangle is the only triangle with the angle measures 60, 30, and 90. What mistake could she have made? Well, it sounds pretty redundant. It sounds like she made the same mistake that I talked about in number 11. She forgot that they could go ahead and then increase the length of the sides. She forgot. She can make other triangles using different side lengths. let's see, that's number 13. We're on to number 15 now. 15 says you are asked to make a triangular sign using the given information about triangle WXY. In triangle WXY, the angle WXY is 45 degrees, so WXY will be 45 degrees. M, the measure of YWX will be 90. YWX, YWX, Y. Okay, all of those are 90. And WX will be 5 feet, 5 feet. Well, then, see, this is 1, 2, 3, 4, and we had a little extra on each side. That's about 5. This is 1, 2, 3, 4, 5, 6, 7. That's not going to work. It's 1, 2, 3, 4, 5. I think this is 6. 1, 2, 3, 4, 5, 6. That's a little bigger. So it says which triangle is correct? Each square on the grid equals 1 square foot. So right off the bat, I'm going to have to say A is the only one that really qualified. The second reason, besides W to X equaling 5 feet, is it says the measure of WXY is 45, WXY. Well, as you know, every triangle equals 180 degrees. So when you add 90 degrees to 45 degrees plus X, you realize 90 and 45 make 135. So you have to subtract 135 from 180. And that's going to give us, let's see, 5, to borrow 1 to make 7, 45 again. So this angle, since this is 45 and this 45, these angles have to be the same. That's why this one's the only one that works. These angles look about the same. This angle looks the same, but this is way too long. It's not 5 feet for sure. And this angle is not the same as this angle, so that would disqualify that one. All right, let's go ahead and worry about, number B, explain why only one triangle can be formed with these 3 precise pieces of information. Well, we just did, right? I'm going to type this out. The remaining angle must be 45 degrees. Let's see, 45 degrees. I'll start at that again, huh? Okay. All right, 45 degrees. And the length of WX is only, I think they said 5, yeah, only 5 feet with triangle A. Okay, triangle A. All right. See, 14 there, so did I put 14 and 15 on twice? I sure did. All right, so we can get rid of 14 and 15 on this one. Let's go to 16. Oh, it looks like, make sure that I didn't accidentally tape something on accident, or copy the wrong thing on accident. Hold on. Your number 17 says 2 triangles have side lengths of 12 units and 15 units, and a non-including angle of 45 degrees. Draw 2 different triangles with these conditions. If I did that, let's see, I could draw, well, this one could have 12. This one could have 15. And this could be 45. But I could also draw one that is 12, 15, and 45. As you can see, both will meet the criteria of the description up here. Number 19, looks like my last one. The triangle has two side lengths of 8.5 centimeters and 9.5 centimeters. What is a possible length for the third side? Explain why this is a possible length. Well, let's take a good look. So on number 19, it says a triangle has two side lengths of 8.5 centimeters and 9.5 centimeters. What is a possible length for the third side? Explain why there's a possible length. Well, what we have to remember is the triangle has to have its two angles that are bigger than, two sides that are bigger than the third side, because if not, I wouldn't be able to touch them. So I need to make sure it's going to be big enough. So this might be 8.5. This could be 9.5. We're trying to figure out something over here. We could put like 2.5 if we want. And that way I know that 8.5 and 2.5 will make 11, and that's bigger than 9.5. All right? So that's why I would do it. I would say, let's see, use any measure let's see, use any side length which let's collect this side length when which will create a sum bigger than 9.5 to explain what use any side length which will create a sum bigger than 95 when combined with 8.5. All right, and that gives us the answer for number 19. I think that's it for me for today, so I'll see you in class.